Okay, this is an explanation for Unit 3 Test Version A, FRQ. So scenario 1, Harley-Davidson is a manufacturer of Great American motorcycles. Harley-Davidson's research and development division are investigating tread life for motorcycle tires. The Harley-Davidson researchers have suggested that a study be conducted to determine whether motorcycle tires produced using a new synthetic rubber compound have a longer tread life than the tread life of motorcycle tires produced using the standard compound. A researcher in the division suggested the study be designed in the following way. Select 100 identical Harley-Davidson motorcycles. It's interesting that they selected 100 identical motorcycles, and the reason they did this was to control for variations between each motorcycle. In other words, some may wear the tires differently than others. So they, by selecting 100 of the same type, they eliminate some outside variables. And randomly assign 50 of these motorcycles to one group and the rest to a second group. So basically we have 100 motorcycles and we're going to randomly assign to 50, to one group of 50 and to another group of 50. All 100 motorcycles will be equipped with front tires produced using the standard rubber compound. So all the motorcycles on the front tire will have the same compound, while the motorcycles in group A will be equipped with rear tires using the synthetic compound, and those in group B will be equipped with rear tires using the standard compound. So basically the front tires for all the motorcycles are the same, but the back tires in group A will have the new synthetic, and the back tires in group B will have the rubber compound. A total of 100 riders will be randomly selected from the population of Harley-Davidson riders gathered in Sturgis, South Dakota, because they are regular riders and represent Harley-Davidson's target market. Basically, they selected 100 riders that are representative of the people they want to sell to. The 100 motorcycles will be randomly assigned to 100 riders, with a different motorcycle assigned to each rider, and the riders will be asked to ride the motorcycle for a 6-month period. At the end of the 6-month period, the researchers will compare the mean amount of rear tire wear for the motorcycles in the two groups. What type of design has been proposed for this study? Well, basically, you have two different treatment groups. You have a treatment group with a synthetic tire in the rear and one with a standard tire in the rear. And we have 100 different subjects, and these are the riders. And basically, they're going to randomly assign them. Well, in this case, they're randomly assigning 100 riders, and the way they're doing that is they're putting all the names in a hat. Even though they didn't tell that, you can surmise, because that's what they're doing, is they're putting all the names in a single hat. When you put all the names in a single hat, or you number all the riders 1 to 100, and you randomly select, because it's a single bin or a single hat, this makes this a completely randomized design. So a completely randomized design, everyone is going into a single bin or single hat. That is different than a block design, where in a block design you're going to have you'll have a hat or bin for every single block. Okay, next thing it asks for the rear tire, it asks for the response variable, and the response variable in this case was rear tire wear. The other thing I want to mention while I'm here is they have 100 riders, and 50 will be assigned to a synthetic A, and 50 will be randomly assigned to synthetic B. Those 50 represent replication. And the reason we use replication is so that we can make sure that we can generalize. If we only choose one person, that one person might have special traits. So by including multiple, we're able to generalize over the variation of several different different people types. Another researcher recommends using a blocking design of 100 riders, 50 of whom are men and 50 of whom are women. So we have a block, 100 riders, and we're going to have 50 men and 50 women. All of the participants have similar riding habits. That's a very important statement. By telling us to have similar riding habits, we can generally surmise that there's not a difference between the men and the women because they're all similar. For the purpose of the study, for their riding habits are, for the purpose of the study, should the researchers block by gender or weight? Once again, they told us that the riding habits are similar, so we're going to assume that there's not a substantial difference in the way the genders ride the motorcycle. However, there could be differences in weight, and weight may impact the study. You always block on the variable that you believe will have the greatest impact on the study. And in the way this is set up, it sounds like weight will have a greater impact than gender on treadwear. So what you should be saying is block on the variable that has the greatest impact. I believe weight will have the greatest impact. I believe that because weight will impact how the tires wear. And they say that the cyclists have the same riding habits, so there's probably not much difference or any difference between genders. Technically, you could make an argument for gender, but you'd have to be careful on how you did so. Then this next one says design and carry out a match pair design. When they're telling you to do this, they want when they say design and carry it out, they want a complete walkthrough of how you assign treatments, what the treatments are, and what you're comparing at the end. Well, in this particular case, we want a match pair design. In a match pair design, you're going to make sure that each subject receives both types of treatments. And there's a couple different ways to have achieved this in this scenario. First thing we need to do is assign to treatment groups. Well, that means I need to know what my treatment groups are. So I'm going to say that treatment group A is a treatment group that has the synthetic tire on the front and the standard compound in the back. Treatment group B has the standard compound in the front and the synthetic in the back. Now I need to assign my 100 riders. Just like in a completely randomized design with a match pair, I'm going to have a single hat and I'm going to put everyone in it. So I put everyone into a hat and mix the first 50, and then I put the names in the hat and mix. The first 50 names drawn will be assigned to treatment group A, and they will receive the rubber in the back first with the synthetic in the front. The other 50 will receive it the opposite way. At the end of time, we will measure the tread wear to see which tire maintains the tread wear the longest. Alternatively, you could have said that, hey, I'm going to put, I could have gone with the original 100 motorcycles that they had, 50 of which had the synthetic in the rear and 50 of which had the rubber, the standard rubber in the rear, at which point you put 100 names in a hat and mix, 50 are assigned to synthetic in the rear, the remaining 50, the 50 drawn or go to the synthetic in the rear, the other 50 get the rubber in the rear. After 3 months, we swap, and then they swap motorcycles, and then we do the same thing again. And so the first 50 that have the rubber in the rear, the rubber on the rear tire will switch to the synthetic on the rear tire, and the others that had the synthetic in the rear tire will switch to the rubber on the rear tire. And they'll have that for 3 months. And at the end of 6 months, we will measure the tread wear to see what differences there were, so we know which one has a greater life. Which of the 3 designs is better? So we basically had, in this case, we had a completely randomized design, a block design, and a match pair design. Typically speaking, a block design is going to be better than a block design is going to be better than a completely randomized design because you are accounting for a variable. In this case, you're accounting for weight. However, the best design is the matched pair design. And in general, the matched pair design is always the best design. And the reason it is because someone was tested twice, and because they're tested twice, we actually control for the differences between each individual. So if you ride in different places, you ride at different times of the day, you are heavier, you ride faster. All those things are accounted for because I got tested twice, so I can go, you know what, this rider wears this tread this much, and wears this tread this much. So the best one is to always use a matched pair. It's not always possible, but when possible, use a matched pair because it controls for differences among the individual subjects, and the others do not. And a matched paired actually is a special type of blocking. It's just been blocked all the way down to the individual. Okay, so this is scenario 2 for version A. There are more than 100 species of poison dart frogs. A mad scientist is interested in studying whether different insects eaten by frogs and different humidity levels in water impact the toxicity of the poison of the frog. The mad scientist has ordered a shipment of young golden poison dart frogs from a supply house for use in the study. The experiment is to be conducted in a laboratory with 25 golden poison dart frogs are placed randomly into each of 24 tanks. So real quickly, if I have 25 frogs per tank, 25 times 24 means I have a total of 600 frogs that I'm going to distribute among the tanks. And yes, I actually changed the number just to make this explanation easier, but we adjusted for that when we were doing the grading. The mad scientist is planning to use 3 different types of insects: crickets, flies, and grasshoppers, and 2 humidity levels, low and high. List the treatments the mad scientist plans to use in this experiment. Well, in this case, we have crickets, 3 types of insects, and 2 types of humidity levels. So 3 times 2 is 6. So I have 6 different treatment groups. So my treatment groups in this case are crickets with crickets with a low humidity, crickets with a high humidity. I have flies with a low humidity, and I have flies with a high humidity. Then I have grasshoppers with a low humidity and grasshoppers with a high humidity. So I have 6 different treatment groups, and I have 24 tanks. So 24 divided by 6 means I'm going to have the same treatment group occur 4 different times. So 4 of the tanks will have the crickets with the low humidity, 4 will have the crickets with the high humidity, etc., until we have 4 grasshoppers with the low humidity and 4 grasshoppers with the high humidity. Anyway, I needed to list all the treatments, and I just mentioned them all. The next one says, using the treatments listed in Part A, describe a completely randomized design that will allow the mad scientist to compare the frog's toxicity after 3 weeks. So basically, I need to randomly assign all the frogs that I got. Well, we know we have 600 frogs. We also know, and so you need to sit there and go, okay, we have 25 times 24, so we have 600 frogs, and we have 6 treatment groups. So basically, there'll be 4 tanks of each type of treatment. So here's what I would do. I would go to tank A, and tank A would be maybe the crickets with low humidity. I've made sure I've numbered all of my frogs from 1 to 600. And then I have little slips of paper that I put into a hat numbered 1 to 600. I'd mix those numbers in a hat and draw without replacement. The first 25 numbers drawn, the frogs associated with that would go into the first tank. I would then draw the next 25 numbers. The frogs associated with the next 25 numbers would go into the next tank. And I would do that for all 24 tanks, for all the 24 tanks. At that point, I've talked about the randomization process. I've also named my treatments, and I've also told you how that they were being assigned to the treatments by saying that I had 4 tanks of each type of treatment group. After 3 weeks, I would take the frogs out and I would measure their toxicity to determine which treatment increased it the most. Give a statistical advantage to having only golden poison dart frogs in the experiment. Explain why this is an advantage. The advantage is I've controlled for differences between the frogs, different types of poison dart frogs. One poison dart frog might react differently to a diet or humidity than the other. So here I've actually narrowed it down and controlled for an outside variable by limiting it to the golden poison dart frogs. That's the advantage. The disadvantages of which it mentioned in the next part. I can only generalize this to the young golden poison dart frogs. It cannot be generalized to all poison dart frogs, but it can generalize to poison dart frogs. Now, please remember, this is not being generalized to the sample. When we generalize to the population. So by having done this, I can generalize to all. I have to generalize to a similar population. Similar population is young golden poison dart frogs. So my sample is a subset of that. So consequently, that's what I can generalize to. Okay, this is test version A, scenario 3. Students with test anxiety sometimes enroll in yoga classes to help them overcome this fear. Typically, 9 to 10 one-hour yoga classes are needed before improvement is noticed. A study was conducted to determine whether the drug Tylenol used in combination with fewer yoga classes would help students overcome their test anxiety. Each of 43 students who participated in the study received a pill before each of 3 one-hour yoga sessions. 26 of the 43 students were randomly assigned to receive a Tylenol pill, and the remaining 17 received a placebo. Here we don't have equal size treatment groups. That's okay. We want to make sure that we have enough to say that we have enough replication for each one to say that we've accounted for differences in the population. So we have 26 in one, and we have 17 in another, and that may or may not be enough to say that, hey, that accounts for the different students, but that we'll see if they ask us about that. After the completion of the 3 one-hour yoga classes, none of the 43 students received additional Tylenol pills, nor did they attend any more yoga classes. So basically, 3 one-hour yoga classes and a pill, and that's it. 3 months after the administration of the pills and the 3 therapy sessions or the 3 yoga sessions, each of the 43 students were evaluated to see if he or she had improved. Was the study an experiment or an observational study? Provide an explanation to support your answer. All right, so the primary thing that you have to say to be an experiment, as treatments had to be randomly assigned. In this case, treatments were randomly assigned to the 2 groups, one receiving a placebo pill and 3 hours of a yoga class, and the other 26 receiving a Tylenol pill and 3 hours of yoga class. So treatments were randomly assigned, so this is an experiment. When the data was analyzed, the Tylenol group showed statistically significantly more improvement than the placebo group did. Based on this result, would the researchers be justified in concluding that the Tylenol pill and 3 one-hour yoga sessions are as beneficial as 9 to 10 yoga sessions without the pill? Justify your answer. Well, while there was a statistical difference, it was between the comparison of the 3 one-hour yoga classes and a placebo versus the 3 one-hour yoga classes and the Tylenol pill. Nowhere in the study was 9 to 10 yoga classes tested. So we have no idea whether the Tylenol pill and 9 to 10 and with 3-hour classes is better than the 9 to 10 because it was not tested. So we cannot make that conclusion because, once again, we tested the Tylenol pill in 3 one-hour yoga classes. We did not test the 9 to 10, so we cannot make the comparison because it was not part of the test. A newspaper article that summarized the results of the study did not explain how it was determined which students received Tylenol and which received the placebo. Suppose the researchers allowed the therapist to choose which students received Tylenol and which received the placebo, and no randomization was used. Explain why such a method of assignment might lead to an incorrect conclusion. First off, randomization is always necessary, and it's necessary to equal out the effects of uncontrolled for variables that might impact the study. So basically, there are things that could impact the study about the individual students that weren't controlled for, and again, randomization equalizes those things. Further, the researchers either intentionally or subconsciously may place people into groups so that the study ends up with specific results. This would be bias. But the primary purpose is, creating a confounding variable. The primary purpose of, and this is the one that you got credit for, is saying that, hey, it is important to randomize to equalize the effects of variables that are not accounted for, to avoid the effects of confounding. Further, it's important to make sure that we don't assign students to a group that we think these will get better easier with this one, and vice versa. We cannot do that. Okay, that tends to bias the results.